last lecture, we have already discussed about rotational dynamics, and in this chapter, we have studied torque acting on a rotating body. Today, we are going to discuss one of the important point in the rotational dynamics, and the name of the point is kinetic energy of a rolling body. Kinetic energy of a rolling body, very important concept. Let us consider a simple example. Suppose that this is a rigid body like a sphere rolls on this horizontal surface. This is a rigid body like a sphere which rolls on smooth horizontal surface. Let m be the mass of the body, m be the mass of the body, r be the radius of the body, v is linear speed of the body, omega is angular speed of the body, I is moment of inertia of that body about an axis passing through center of mass, and k is the radius of gyration of the body about an axis passing through its center of mass. Then we know that when this rigid body, any rigid body like a sphere or cylinder or a wheel rolls, it performs two motions simultaneously. That is, rolling motion is the combination of two simultaneously occurring motions, that is translational motion as well as rotational motion. And this combination of two simultaneously occurring motions, translational and rotational motion, is called rolling motion. And today we are going to derive an important expression, that is expression for kinetic energy of a rolling body. This kinetic energy of a rolling body is equal to sum of kinetic energy of translational body as well as kinetic energy of rotational motion. Okay? Therefore, we can write E equal to kinetic energy of translational motion is E equal to 1/2 mv square. This is the kinetic energy of translational motion plus kinetic energy of rotational motion is 1/2 I into omega square. 1/2 I into omega square. Kinetic energy of a rolling motion is the sum of kinetic energy of translational motion and kinetic energy of rotational motion. Kinetic energy of translational motion, we know that formula is 1/2 mv square. Kinetic energy of the rotational motion, we know the formula for kinetic energy of rotational motion is 1/2 I into omega square. Suppose this is equation number 1. But we know that I is equal to mk square, where k is radius of gyration of the rotating body, and we can write omega square equal to v square divided by r square. We know the relation v equal to r into omega. Therefore, v square is equal to r square into omega square, or omega square equal to v square divided by r square. Let us substitute these two values, that is value of r and value of omega square, in equation number 1. We can write kinetic energy of a rolling body is equals to 1/2 mv square plus 1/2 I equal to mk square into omega square equal to v square by r square. If we observe these both terms, there is a one common term, 1/2 mv square is the common in both the terms. Therefore, this equation can be written as E is equal to 1/2 mv square common into bracket 1 plus k square by r square. Very important expression. This is an expression for kinetic energy of a rolling motion. M is mass of the body, v is linear speed of the body, k is radius of gyration of the body about an axis passing through its center of mass, and r is radius of the body. Okay? Now this equation we can also derive in terms of angular speed. This equation 2 gives kinetic energy of a rolling body in terms of linear speed v. Now we are going to derive expression for kinetic energy of a rolling body in terms of angular speed omega. Now, in equation number 2, we can write v square is equal to r square into omega square. We know the relation v equal to r into omega. Linear speed is equal to radius of circle into angular speed. Therefore, v square equal to r square into omega square. Putting this value of v square in equation number 2, we get the equation E equal to 1/2 m r square into omega square. Value of v square is r square into omega square into bracket 1 plus k square divided by r square. This equation we can also write as E equal to 1/2 m into omega square multiplied by r square to the both terms in bracket. We can write E equal to 1/2 m omega square r square into 1 r square plus r square into k square by r square k square. And this is expression for kinetic energy of a rolling motion in terms of angular speed omega. Equation 2 gives kinetic energy of a rolling motion in terms of linear speed v. Both these equations are very important equations. Okay. Kinetic energy of rolling motion is sum of kinetic energy of translational motion and kinetic energy of rotational motion. Therefore, E equal to 1/2 mv square plus 1/2 I into omega square. This is the kinetic energy of translational motion. This is the kinetic energy of rotational motion. In this equation, we can write I equal to mk square and omega square equal to v square by r square. We can write the equation E equal to 1/2 mv square plus 1/2 mk square into v square by r square. Therefore, E equal to 1/2 mv square common into bracket 1 plus k square by r square. This is expression for kinetic energy of a rolling motion in terms of linear speed v. This equation we can derive in terms of angular speed omega. Now, in equation number 2, we can write v square equal to r square into omega square. Therefore, equation 2 becomes E equal to 1/2 m r square omega square into bracket 1 plus k square by r square, or E equal to 1/2 m omega square r square in bracket r square plus k square. R square into 1 r square. R square into k square by r square k square. This is expression for kinetic energy of a rolling motion in terms of angular speed omega. Now, we are going to study this rolling motion on an inclined plane. Next point is rolling motion on an inclined plane. smooth horizontal plane. Now we are going to study rolling motion on an inclined plane. Let us see the figure. Suppose this is horizontal plane. This is horizontal plane. This is an inclined plane. This is horizontal plane. This is inclined plane. Okay. This angle theta is called angle of inclination. Angle between horizontal plane and inclined plane, theta, which is called angle of inclination. This height h is called height of inclination. Now suppose that a rigid body like a sphere rolls on that inclined plane, okay. Initial velocity of that sphere, suppose u equal to 0. M is mass of that sphere, R is radius of the sphere, U initial speed of the sphere, which is equal to 0, V be the final speed of the sphere when it reaches the bottom of the inclined plane. V is final speed of the sphere when it reaches bottom of the inclined plane. Let I be the moment of inertia of the sphere about an axis passing through its center of mass. K be the radius of gyration of the sphere about an axis passing through center of mass of the sphere. Angle theta is called angle of inclination. This height h is called height of inclination. Now we have to calculate this linear speed v of the sphere when it reaches bottom of the inclined plane. When sphere reaches bottom of the inclined plane. Okay? We know that here when that sphere when reaches the bottom of the inclined plane, the gravitational potential energy of the body converted into kinetic energy. Gravitational potential energy gets converted into kinetic energy. Therefore, we can write loss in potential energy equal to gain in kinetic energy. Loss in potential energy equal to gain in kinetic energy. When this sphere rolls down on an inclined plane and it reaches the bottom of the inclined plane, the gravitational potential energy of that sphere converted into its kinetic energy. And therefore we can write loss in potential energy equal to gain in kinetic energy. We know that loss in potential energy is mgh. mgh is loss in potential energy when it reaches bottom. And that is equal to gain in kinetic energy. We know that that sphere rolls on inclined plane and the kinetic energy of the rolling motion is 1/2 mv square into bracket 1 plus k square by r square. Loss in potential energy is mgh. M is mass of the body, g is acceleration due to gravity, h is height of inclination, okay, k is radius of gyration and r is radius of the sphere. Okay. Therefore, loss in potential energy mgh equal to gain in kinetic energy, that is kinetic energy of the rolling motion, which is equal to 1/2 mv square into bracket 1 plus k square divided by r square. Gets cancelled from both sides, and we have to calculate linear speed of the sphere when it reaches bottom. Therefore, we can write v square equal to this term 2 in the denominator can be taken in numerator. V square is equal to 2gh, and this term 1 plus k square by r square in the numerator can be taken in denominator. 1 plus k square by r square. Taking square root on both sides, we can write v equal to square root of v square v, and that is equal to square root of 2gh divided by 1 plus k square by r square. Very important expression. This is the expression for velocity acquired by the rigid body when it rolls down and incline the plane. Okay? Let us see this equation. Loss in potential energy equal to gain in kinetic energy. Loss in potential energy is mgh and gain in kinetic energy is 1/2 mv square into bracket 1 plus k square by r square, which is the kinetic energy of rolling motion. Gets cancelled. V square equal to 2gh, 2 in the numerator, 1 plus k square by r square taken in denominator. Taking square root on both sides, we get the equation v equal to square root of 2gh divided by 1 plus k square by r square. Very important equation. This is expression for velocity acquired by a rigid body when it rolls down on an inclined plane. Now we have to calculate a linear acceleration of the body when it rolls on an inclined plane. We have to calculate linear acceleration A of a rigid body when it rolls on an inclined plane. We know kinematical equation we have already studied. In 11th standard, there are 3 kinematical equations. First one is v equal to u plus at. First kinematical equation. Second kinematical equation, s is equal to ut plus 1/2 at square. And third kinematical equation is v square equal to u square plus 2as. We have already calculated the value of v. Now we have to calculate linear acceleration A. Displacement yes. We have known the displacement yes. Therefore, we can use the third kinematical equation to calculate linear acceleration. Okay? By using third kinematical equation, we can write v square equal to u square plus 2as. Okay? U is initial speed of the body, v is final speed of the body, a is linear acceleration of the body, and s is the displacement of the body. And we know that if we observe this figure, from figure we can say that sin theta equal to h by s, and therefore h is equal to s sin theta, or s is equal to h by sin theta. Okay. This initial velocity u of the body is 0. Therefore, we can write this equation as v square equal to 2as, u equal to 0. Therefore, v square equal to 2as. Value of v square we have already calculated in last expression. V square is equal to 2gh divided by 1 plus k square by r square. That is equal to 2a into value of s is h divided by sin theta. H divided by sin theta. Value of v square. Velocity of the body when it reaches the bottom is under root 2gh divided by 1 plus k square by r square. Therefore, v square equal to 2gh divided by 1 plus k square by r square, and that is equal to 2a. Value of s is h sin theta. h divided by sin theta. Okay. 2h gets cancelled. 2h gets cancelled. And therefore, we can write the equation as a equal to the sin theta in denominator taken in numerator. A equal to g sin theta divided by this term 1 plus k square by r square. Very important expression. This is an expression for linear acceleration of a body rolling down an inclined plane. This is the third kinematical equation. V square equal to u square plus 2as. In this equation, we can write initial speed of the body is 0. Therefore, equation 1 becomes v square equal to 2as. We know the value of v square is 2gh divided by 1 plus k square by r square, and that is equal to 2a. Value of s is h by sin theta. 2h gets cancelled, and therefore final equation we calculate a equal to g sin theta divided by 1 plus k square by r square. This is an expression for linear acceleration of a body rolling on an inclined plane. In this equation, we know angle theta is called angle of inclination, g is acceleration due to gravity, k is radius of gyration of the body about an axis passing through center of mass, and r is radius of the